Tonight we're going to explore those three-dimensional solids we have been talking about, and we're going to find the formulas and the ways to find the surface area and the volume. Now remember that surface area is kind of like you're wrapping a package, and volume is how much rice fits in the jar. Okay? You will not mind volume. You will mind surface area, probably. So a little more vocabulary to get us started, and the first word on your sheet should be polyhedron, and that is a solid that is bounded by polygons. So any one of those figures we've already talked about would be a polyhedron. Okay, it has to be bounded by polygons. So a cylinder is not a polyhedron because it does not have, its bases are not polygons, they're circles. The surface area is the total surface of a three-dimensional object in units squared. We're talking about area here, okay? So that, again, is how much wrapping paper do you need to cover the box. The lateral surface area is the surface area of any three-dimensional, here it comes, object, wait for it, excluding the bases. Okay, it's kind of coming in a little slow. I'm not sure what's going on. And that is, again, in units squared. So that's, kind of like if you're painting a house. Okay, you don't do the roof and you don't do the underneath the house. Then the volume is the amount of space occupied by a three-dimensional object. And that, again, is what you would need to fill a pool or something like that. And that is in units cubed. So for finding the surface area and the volume, you need to use formulas. And that's just a set of instructions to tell you what to do. You look at the picture, you identify the parts, and you plug it in. Now, here's my warning on formulas. Unless you're really good at memorizing, you better understand what the formula does, because if you forget the formula, you can always rely on your knowledge. So these are all of our two-dimensional formulas that you should know. Okay, there's a little cheat sheet for you. You know most of those. And if we look at a rectangular prism, you have to think about all the surfaces. It can be done using a formula, or you can find the area of each surface and add them up. If you think about it, it's the same thing. 2LW. Well, if I think of this as my length here, and this is my width here, that's going to be my top and my bottom. 2 length times height is going to be the front and the back, and 2 width times height is going to be the left and the right side. Or you could just find everything and add them up. Either way, you're going to get the same answer. But if you memorize this, you better be sure you know what it means, because otherwise you're going to be stuck. Okay, the volume of any three-dimensional figure. Now, this is not going to stay on here. It's going to disappear because I'm in a PowerPoint. But it's always, volume is always capital B times H, where capital B is area of the base. Okay, so it's always area of the base of a figure times its height. Well, the area of a base of a three-dimensional figure, three-dimensional prism, is length times width. So that's why this formula works the way it does. Very important to understand why we get these formulas, because then if you happen to forget them, you can always go back to your base knowledge. Okay, so to find the surface area and the volume of this, you should really try this on your own. Okay, you really should pause here and try it on your own, and I'll come back and give you all of the work. All right, so the front and back is your length times your height. The left and right is your width times your height, and the top and bottom is length times width if you did this using the formulas. 232 centimeters squared either way. Volume is easy, length times width times height, which is 224. Make sure you have a centimeters cubed there. Okay, now we talked a little bit about nets. Nets are very important in your understanding of mathematical shapes. If we unfolded it, what would it look like? So a triangular prism has triangles on either end, and then it kind of wraps around the triangle. Okay? Notice there are 2 congruent triangles and 3 rectangles. This one looks like it could be an equilateral triangle, but you can't assume that. Okay? That's where it says the rectangles may or may not be the same. So you're finding each area of these, it could be a scalene triangle. Each of these guys could be different, okay? So you need to remember that. So we're going to find the area of each surface, the top and the bottom, which is a triangle, which is 1/2 base times height. In this case, they told us it was isosceles, so that's going to be 18. The two dark sides then are the same, because if you think about the 6 and the 6, okay, this 6 and this 6, they're the same length. This height applies to both, and then I have 6 and 6 again, and this height applies to both. So 1 and 2 are equivalent. So I can just take those two and add it up twice, okay, which is what they did here. Okay, those 54s. And then this one in the back that I'm going to color in red now, this guy is totally different. It's 8 millimeters by 9 millimeters, which is 72. So we just add up all the parts and we're good to go. Surface area, again, can be kind of trying. Okay, you have to be attentive. The volume, again, it's area of the base times the height. So right now in your head, think mental math. What is the area of my base? It's a triangular prism. Prisms are named for their bases. So the base is a triangle. So what is the area of that triangular base? And then multiply that by the height. Okay? So the volume is going to be the 1/2 base times height, which is my capital B. Okay, volume is always, a standard formula for volume is area of the base times the height. Base being whatever the base is. So in this case, it's a triangle. And again, remember your millimeters cubed there, okay? All right, let's move on. Okay, yeah, there's just a little explanation of what I already told you. Okay, now a cylinder is very interesting, and I need everybody to tune right in here and pay attention. No distractions. All right, if we're thinking about the can, okay, think about a can and we open it up to form its net. All right, now look at this can. And I know that I want all of these different dimensions here. You can see the surface is made up of 2 circles and a rectangle. Well, how do those relate? Think about it. This rectangle has to wrap around that circular base. So, the length of the rectangle, concentrate right now, this length is the circumference of that circle. So they do not need to give you very much information at all when you're finding the surface area or volume of a cylinder, because this circumference is going to be the length of that. Now this is the height of my can, okay? So this asks us to round to the nearest tenth. You have one there. So there is a formula that I will give to you, the surface area formula. I will give that to you. But before I do, so to leave that blank for a minute, to find the surface area, we have to find the area of the top and the bottom of the circle, which is 30.2. I have 2 of those because I took 3.1 and I squared it, and then I multiply it by pi and answered to the nearest tenth. The rectangle has a length of pi d. Very important. Do you see that? The length of my rectangle is pi d because it goes all the way around, and the height is 12. So I have to find the circumference, which is 19.5, because it's pi times the 3.1 times 2. This is my radius times 2. And then that gives me 19.5. And then the length times the width is going to be 19.5 times that 12. Okay? So the surface area formula that you would plug into, I'm going to give that to you, even though I'm not a fan of formulas. Okay, so here is the formula for the surface area of a cylinder. Now, if you think about this, some people find it easier, but some people mess up this formula in a big, bad way. Okay, so if you think about it, that's just plug and chug, what I call in math plug and chug. What I don't like is the fact that this formula leaves you open for a lot of error if you don't know what it means. All right, the 2 pi r squared is 2 of my circles, right, that top and bottom. The 2 pi r h is, this is my circumference, okay, of that circle, and the height of my cylinder. So if you think about this, oops, If you think about this cylinder, this is the circumference, which is also the length of the rectangle wrapping around it. So that's where I get the 2 pi r. That's, remember the circumference formula? Okay. I just caution you against being a memorizing formula person. And they say the answers are really close, but they're not the same because we rounded in the other problem and rounded here too. Volume, you will not mind so much. It's area of the base times the height, which is here's the area of my base times my height. So plug and chug, and then our final answer is in units cubed. Okay? All right. So what I would like you to do here is try to solve these problems on your own and then come back and check the answers, okay? So really you should try to challenge yourself and do these on your own. All right, so the surface area is going to be 756 centimeters squared, and I think that volume might actually be wrong. I think it might be 972 centimeters cubed, if I'm not mistaken. I have mine written in there as 972, so that might have been an error. And when you do the cylinder, the surface area is going to be, they did the volume first actually, and the surface area is, come on, there we go. I had 112 pi. Rounded to the nearest tenth is going to give you 351.9. Should be 351.9 meters squared. Okay? Great job tonight. I'll see you tomorrow.